Why are the collections of stars in the universe not the same shape? The diverse forms of galaxies seen across the cosmos, from spirals to ellipticals, are not arbitrary. They appear to be different stages in a long process of cosmic evolution, shaped by star formation, gravitational interactions, and mergers over billions of years. Many galaxies exhibit a spiral structure. These objects are defined by a bright, central bulge of older stars, surrounded by a flat, rotating disk. Within this disk are prominent arms that spiral outwards, glowing with the blue light of young, hot stars. These arms are regions rich in gas and dust, acting as stellar nurseries where new generations of stars are actively forming. The spiral galaxy is a dynamic and active system, a place of ongoing creation. In contrast, other galaxies appear as massive, featureless ellipticals. These are huge, spheroid-shaped collections of stars that lack the distinct arms and flat disk of a spiral. Their light is typically redder, indicating they are composed mainly of old stars, with very little gas or dust remaining. They are often found in the dense centers of galaxy clusters, where interactions and mergers are common. Between these two primary types lies an intermediate form, the lenticular galaxy. Lenticular galaxy possesses a central bulge and a disk, much like a spiral, but it has no visible spiral arms. This lack of arms is because it has used up much of the gas and dust that would fuel new star formation. They are composed mostly of older, aging stars and are thought to represent a transitional phase between a spiral and an elliptical galaxy. A third major class of galaxy is the irregular. These objects lack a discernible shape or structure, appearing as chaotic collections of stars and gas. This chaotic appearance is not random, but is thought to be the direct result of gravitational interactions or violent collisions. With larger neighbors that have distorted their original form, they are often smaller than their spiral and elliptical counterparts and are marked by intense, disorganized bursts of star formation. The mechanism that drives much of this galactic evolution can be seen in action across the universe. Astronomers observe many examples of interacting galaxies, where the mutual gravity of two approaching galaxies distorts their shapes long before they touch. This gravitational influence can pull out long, faint streams of stars and gas called tidal tails, stretching for hundreds of thousands of light years and signaling a future collision. When these interactions culminate in a collision, a galactic merger occurs. As two galaxies merge, their ordered structures are disrupted, and the gas within them is compressed, triggering a massive burst of star formation known as a starburst. Over billions of years, the chaotic aftermath of this merger can eventually settle down, with the combined stellar populations forming a new, larger, and often elliptical-shaped galaxy. The variety of galactic forms tells a story of cosmic evolution. The active star-forming spirals appear as the youthful stage, while the large quiescent ellipticals represent a state of maturity. This progression suggests that the grand architecture of the cosmos is not static, but is a dynamic environment where galaxies are constantly and slowly being built, transformed, and reshaped by gravity.